All right, today is a very short lesson, 3.1 average rate of change. So we're going to start. So for 3.1 average rate of change, you are going to, in your notebook, write down the following formula and examples, and then you're going to complete the rest of the do now. Okay, so the definition that we have here is the average rate of change function is defined as the average rate at which one quantity is changing while respect to something else is changing. So basically we have our input is changing and what is the effect on our output kind of situation, okay? In simple terms, an average rate of change function is a process that calculates the amount of change in one item divided by the corresponding amount of change in another item, okay? So read through it again, pause for a second, read through it again, and write this in your own words. Now, formula. So the formula for average rate of change is A of X equals F of B minus F of A over B minus A, okay? Where F of A and F of B are values of a function. So F of B and F of A are just an ordered pair of some sort. An input that responded to some output, and independent with this dependent. So we would have, So we would have A, comma, F of A, that's 1. And we would have B, comma, F of B, and that's the other, okay? And the beauty about average rate of change is that it works for all functions. And it should feel and look very familiar to slope. It's the change in our y over our change in our x, okay? The difference is that average rate of change applies to all function, whereas when you're talking about slope, which is a constant rate of change, that only applies to linear functions. So here's our example. Example 1 is a linear function, okay? So we have f of x equals 3x plus 12, right? And we want to find the average rate of changes. X changes from 5 to 8, okay? So looking here, the first thing you're going to do is you're going to identify your A, which is your smallest number on the interval, and B, which is your largest number on the interval, okay? So then f of A equals 3 times 5 plus 12, which is going to give me 8 plus 12, which is 20. Okay. F of B, I meant to write the 8, is f of 8, which equals 3 times 8 plus 12, which is going to give me 24 plus 12. 24 plus 12 is going to give me 36. Okay. So now that I have established my A, my B, to find the average rate of change, your A of X, your average rate of change, it's your F of B minus your F of A. So we have 36 minus 20 divided by your B minus A. So that's 8 minus 5. Okay, guys, let's blame Ms. Jones on her nonsense. What was she doing here? Who knows? I should have written it all the way out. That is not correct. I was like, this is not what's in my notes. Whew. Sleep is important. F of 5 equals 3 times 5 plus 12, which equals 15 plus 12, which equals 27. Let's try that again. All right, here we go. So we have 9 over 3, which equals 3. Okay, remember how in the previous I said that for a linear, which this is, regardless, the average rate of change is going to always be its slope. And was that the case? Yes. So the average rate of change for any linear function is going to always be the slope, because no matter what, 2 points are going to be the same distance. Well, have the same constant rate of change from one to the other. Okay, now let's look at a non-example of average rate of change. Okay, you're going to still do the same steps. Identify your starting point of your interval and the ending point of your interval, and you're going to find their f of A and the f of B. So here we have A, we have B, and our function is f of x equals x squared minus 9x. So I'm going to find f of A, which equals f of 2, which equals 2 squared minus 9 times 2. That's going to give me 4 minus 18, which equals negative 14. There we go. Okay. Now we're going to do f of B. So we have f of B equals f of 7, which is going to give us 7 squared minus 9 times 7, which equals 49 minus 63. 49 minus 63 gives us negative 14. Okay. All right, so then now we're going to find our average rate of change, our A of X, which equals our F of B minus our F of A. So negative 14 minus negative 14 divided by B minus A, which is 7 minus 2, which equals 0 divided by 5, which is 0. So the average rate of change on the interval from 2 to 7 would be 0. Okay, now we have concluded the average rate of change for the most part of our notes. And now all you're do now, you're going to still use f of x equals x squared minus 9x, and you're going to find the average rate of change given other intervals. All right, here we go. Oh, sorry, hold on. I wanted to explain to you graphically what this looks like. So graphically, what you have here is a quadratic, right? The quadratic is at the origin because it's at 0, right? And then it says x squared minus 9x. So we know that we're at 0. And then we're also at 9. Yeah. But our quadratic here, it is doing, I'll make it pretend that's 9. It's going like this. Okay. And we're saying that at f of 2, so at f of 2, which is somewhere here, f of 7, somewhere here, we're all the way down here. And it's just asking you, what is the quickest way for me to get from here to there? And in this case, from here to here, to get from here to here, it's going to be a horizontal line because their values are the same. So there isn't any change. Our average rate of change here is that they're going to, the change in our x and our change in our y are going to cancel out each other, and it's just going to be 0. Because remember, what's the slope of a horizontal line? 0. And that's what this would look like graphically if you were finding it. Okay.